As most of you were aware, this is the second session of our actual course, right? So earlier we had a demo session, and then we had a briefing session actually, wherein we have discussed about the prerequisites of what Hadoop is and how the things in Hadoop do work. I mean, where do Hadoop fit? How can I compare Hadoop with RDBMS? So these were the details that we have discussed on a high level in our previous session. But for the people who had missed either demo video or the first session, you need not worry, right? So what you can do is, you can probably after today's session, I'll be talking to your consultancy folks, and then I will be sharing the videos with them, and they would be sharing the videos with you in turn. So that would be the plan. But anyways, today's session and previous sessions are nowhere related, so you need not bother about that. You need not bother that you have missed previous sessions. That's the first thing. Second thing, when you watch the demo video and previous session, you would understand what all activities that we do perform in this course. And the second thing is, we are also gonna aware how the course is gonna progress. I mean, what all topics are we going to cover throughout this course. So these are the details that I would have already covered in the demo video or in the day one session. Just go through it, you'll get better picture. Okay, so as part of today's discussion, I would like to convey few more prerequisites of Hadoop or the jargons of Hadoop before we actually enter into the architecture of Hadoop. One has to understand few basic things. So that's what I'm going to convey now. So let me open a notepad here. Yeah. So let me talk about the distributions of Hadoop available. So what all distributions of Hadoop are available in current day market? But first of all, what is the distribution you're talking about? See, we already know Hadoop is an open source, right? It's a framework that is built in Java. And the main purpose of Hadoop invention is to store and analyze big data. So when I say big data is a term to coin large data sets that are difficult to be stored or analyzed in a traditional RDBMS. So why it cannot be stored or analyzed, we have already discussed that in detail. So Hadoop is a framework that is built in Java to store and analyze big data. That's the term. That's the definition, I should say. And one has to understand that Hadoop is an open source. Okay. The first and foremost thing that people do ask you is, when you are attending an interview, hey, what's the distribution of Hadoop you have worked on? Or what's the size of a cluster that you have worked on so far? So these would be the questions people would ask you at the first moment when you enter into an interview, right? See, I would like to tell you one more thing which I've missed in our previous sessions. Basically, what I would do is, after a couple of days, I would be sharing this particular PDF with you, which is some interview questions that you can expect from each and every echo component available in the Hadoop or the architecture that we have, right? So what you're supposed to do is, I'm not going to explicitly run you through this PDF, but what you are supposed to do is, after end of every section, go back to that PDF and answer the queries there. But because I would have already covered those concepts in our course, it's you who has to go back and look at the PDF and answer those interview questions, right? So that's another exercise that I missed to convey you in our previous session. So that gives you confidence with respect to interviews as well. How do you crack interviews soon after the course ends? Okay. Now, coming back to our discussion, So people would ask you, hey, what's the distribution that you worked on? So that means this open source Hadoop is distributed by different vendors. So you might have already heard about few distributions like Cloudera, Hortonworks, MapR, IBM Big Insights, DataStax. So there are many more, but these were the popular ones, popular distributions of Hadoop available in the current day market, right? So I mean, you can ask me, hey, which distribution should I learn? Should I learn everything? This is the most common question people do ask me. See, it's very simple. When you look at Linux, Linux is an operating system which is distributed by Red Hat, Solaris, or IBM. Different vendors are there, right? Similarly, Hadoop is an open source which is distributed by Cloudera most popularly, and then the popular ones comes Hortonworks, and then MapR, IBM Big Insights, DataStax. These are the ones who have been distributing Hadoop. So at the end of the day, the baseline is Hadoop only. So you either work on Cloudera, Hortonworks, MapR doesn't differ. I mean, at the end of the day, you are working on Hadoop. In any of the distribution you do work, you are working on Hadoop. So one has to remember that. There will be slight modifications across the distributions, especially in these three distributions, the first three distributions, which I'm going to convey going forward when we deal with the other eco components of Hadoop as well. So one has to remember 90% all these distributions are similar, right? So there is no change. At the end of the day, you are working on Hadoop. One has to remember. So we would be working primarily on Cloudera Hadoop, right? So if an interviewer asks you, hey, what's the version of Hadoop you did work on? Sorry, what's the distribution of Hadoop you've worked on? You can simply say Cloudera or Hortonworks or Mappa. But in this course, I would be using Cloudera. Okay, now the next question is, what's the size of cluster you've worked on? So what's a cluster? That's something that we have discussed already. Hadoop is a distributed system. Everyone knows that. So in this distributed system, I have multiple systems or multiple nodes, right? So multiple nodes who would work together, that is there in Hadoop to achieve distribution, which we already know. So I have a node, that is fine, but I have group of nodes arranged together, that is called rack. So when I have group of racks, I call that as a cluster. So there you go. Cluster is group of racks, a rack is group of nodes. So when someone asks you, hey, what's the size of the cluster that you've worked on? So what's that answer that I have to give them? I would say probably, hey, I've worked on 100 node cluster. That means in the cluster that I've worked on, there are 100 nodes. Okay, is that it? Or should I answer anything? Yes, you should answer them. What's the entire size that is available in this cluster? Maybe somewhere around 5 petabytes of size, right? Or probably 1 or 2 zettabytes. You can answer them with the size as well. You have to answer them basically. So when someone asks you what's the size of the cluster that you've worked on, the simple answer is the number of nodes and also the size. So I could have worked on 100 node cluster with 3 petabytes of size or 5 petabytes of size, right? So distribution is Cloudera, and the size could be anything that you can tell them. Ideally, you can tell them you've worked on 100 node cluster with one with 3 petabytes of size, right? 1 second, please. let's understand about the versions that you're working on. Like I told, we would be working with Cloudera Hadoop. The current version of Cloudera available is somewhere on 5.7. But the stable version is 5.5. I mean, you might think, hey, should I remember all these things? It's always good you to be prepared with all these things so that you don't fumble when someone asks you these questions right away, right? And the Hadoop current version is 2.7, right? Which is a stable version, major release. So the Hadoop version would be same across all the distributions, and those distributions also do maintain their own version, which is like Cloudera now is having 5.7, which is the current version available, but the stable version is 5.5. To be specific, it is 5.5.2, right? That's the stable version available in the current day market. So there you go. So you understood what is the distribution of Hadoop. You understood what could be the size of the cluster that you could answer them that you have worked on, right? Now, I would like to talk about types of processing. See, basically what I'm trying to do here is I'm making you prepared for all the jargons of Hadoop. Down the lane, when I go to the architecture or when I go to the practical aspects, if I say, hey, we are going to work on a cluster, you shouldn't get doubt what's a cluster, right? And if I say, hey, we are going to work on batch processing, or we are going to work on real-time processing, or near real-time processing, you shouldn't be skeptical about what this could be. So that's the reason why I'm conveying this at the first point, and then I'll be taking you to the architecture so that architecture will be a cakewalk for you. So these are the types of processing layers available in any organization. So let's deal with one after the other. And then I'll stop here for your questions before I proceed any further after discussing about types of processing. So first discussion is batch processing, what this could be. So most of you might have worked on it. So batch is nothing but when you are processing your data in batches, that's what called as batch processing. So you can ask me, what could be the batch time limit? For example, if you are running the processing once in a day, maybe once in a week, once in a month, or once in a quarter, that particular range falls under batch processing. So which means that batch processing would run with a very huge interval, basically. Maybe once in a week, once in a month, or most heavily used batch processing is once in a day. So simple, classical example I can give you is your bank's EOD balance. You would have got an email alert every day saying that, hey, this is the bank balance you have as per today's close of bank, right? So how do they calculate that? They wait, to send that statement to you, they wait for the entire day, and at the time of the bank closure, they calculate all your transactions, let it be debits or credits, and what is the outstanding balance in your account is something that they send as an alert of your statement to you. That means they are processing your entire transactions once in a day, right? And probably today at 6 p.m. EST, they would have sent you an email alert. A bank would have sent you an email alert, and you would get the next email alert in next day 6 p.m. EST, right? So one day interval is there. So that's batch processing. But one has to remember, like I told, it can be once in a day, or you can treat it as week or month, right? There could be quarterly and yearly jobs as well. But When I'm running once in a day, once in a week, or once in a month, the amount of data that my processing would run might be very huge. Look at the same thing when I spoke about EOD balance. How many customers should they have to process, right? And for each customer, they have to look at the transactions. Maybe if you're an individual customer, you may not do much of transactions. But if you are maintaining this as a business account, wherein you do some thousands of transactions per day, so that means bank has to process many transactions for a single account. But imagine the bank has to process for all the accounts available within the bank. So how long would they take? So batch processing, though it runs once in a day or a week or a month, it runs for little longer time, and that runs on top of very huge data sets. One has to understand that, right? So that's about batch processing. So coming to near real-time processing, I'll tell you what. For example, you have to run some processing every half an hour or every 15 minutes, every 10 minutes. That means some data has been generated and you're processing that after 10 minutes or 15 minutes or 30 minutes. That means you're running them in micro batches. You're not taking whole day, whole week, whole month. Rather, you're taking only 10 minutes or 15 or 30 minutes, which comes under real-time processing, right? I'll tell you an example. For example, you belong to an organization where you maintain some events. For example, you're selling some products to the customer. Customer would log in to the organization account and he gives his feedback. He says, hey, I'm very much satisfied with this product. It's a positive feedback. He says, or he's calling to your IVR rather than logging to your website. He's calling to your IVR for some reason and he's giving a positive feedback. Okay, so that's an positive event. If he's saying that, hey, I'm not totally satisfied, there is some problem, and he had explained his problem. So that's a negative event. And he has called for just some inquiry. He has called just to inquire his current status or something. So that's a neutral event. So you have got three segregations of event: positive, negative, and neutral. Okay. So when there was a negative event, that's when you have to act immediately. When I say immediately, it may not be immediately after 1 minute or so, but if a customer says he's facing some problem with so and so, so what you have to do is you have to concentrate on that negative event and see what's the background behind this issue that customer had raised, and you will have to work on the resolution part as soon as possible, right? So that's why near real-time processing works on micro batches, and that helps you to improve the customer satisfaction, right? I'm just throwing an example here. One example that you can imagine to understand what could be the I'm talking about near real-time processing. I'm not talking about real-time processing. Real-time processing should happen every microsecond. So I'm talking about near real-time processing, which happens in micro batches, like 15 minutes or 10 minutes or 20 minutes. So probably a negative event has happened that you have to analyze and understand the background and give a resolution to the customer, right? For that reason, you're collecting all the events for every 15 minutes, and then you're running your processing layer on top of it to understand what could be the reason. But as soon as the customer raises an event, you're not acting on it. You have 15 minutes or 30 minutes delay, right? So that's about near real-time processing, but the data that near real-time processing takes may not be as huge as batch processing, right? So you could understand here, right? Why the amount of data decreases because you're already processing it for every 15 minutes. You're not waiting for the whole day. And coming to real-time processing. Real-time processing is something that you could imagine that everything has to run just like that. As soon as it triggers, you have to act on it. The best classical example I could give you is stock market updates. So the stock market updates are something like, for example, let's take a stock, and if that stock price is going up, you should see a green colored arrow going up. If the stock update is coming down, you should see a red colored arrow showing you down. And that cannot be updated once in an hour or once in a day. It has to happen as soon as it triggers. Right, as soon as there is some changes in your stock update, that has to be that has to be immediately shown there. So they don't have any purpose of delay there, and there shouldn't be any delay as well. So there every event will happen every microarray second. So that's what called as real-time processing. All these stock market updates, sensor alarming systems, sensoring systems, all these do work on real-time processing. So for example, you are working on a sensor mechanism. So whatever a particular sensor releases, you have to immediately capture them, right? And you have to process them, and you have to convey some result. So there shouldn't be any delay here. You have to immediately capture, you have to immediately convey what could be the end result. So that's about real-time processing. So having said these types of processing, where Hadoop is fit into primarily and where RDBMS is fit into primarily, I would say Hadoop is fit into all these three processing layers. Let it be batch, let it be near real time, let it be real-time processing. Whereas RDBMS predominantly falls under your batch processing, right? I hope everyone is clear with this. If you have any questions with whatever we've discussed so far, I'll wait here for a couple of minutes. You can answer you can post all your queries. I would answer them. You can either use raise your hand option, or you can probably ping it in the chat window so that I would take it from there. Okay. Mukesh, I don't think you have missed anything, right? The session has just started. So what is a batch? Yeah, like I told, a group of data that is accumulated for one day is called as a batch. Okay, because you are running once in a day, so you are accumulating the data that needs to be processed for all the day, and you are running it. That particular time interval, one day, is called as a batch. And Hammond has asked a good question. Is the data processed by a retail bank big enough to qualify as big data? Obviously, but see, it all depends upon amount of data they produce. If you're talking about petabytes of data, if you're talking about thousands of terabytes of data, or thousands of gigabytes of data, yes, it's a big data. Okay. Can you give me an example? Okay, there are a lot of questions coming up. Can you give me a real-time example for near real-time processing? The one I've given is a real-time example, but let me refine that once again, probably after I answer all your queries here, Sidhu. Yeah, how the real-time processing works on Hadoop. Can you give an overview? Yeah, sure, Lakan. I would say it this way. Yeah, for real time, I would give one practical example, or I'll give it for near real time as well. First, I'll start with near real time, one practical example that we've worked on. Same thing. So we have developed a framework that collects the customer events. Okay, it's not about the feedback, it's about the customer login events. For example, let's say Lakan is a customer of a bank. Okay, and he has used his online app to log into the bank portal. Maybe he wanted to do some transfer or something. He's trying to log in, but unfortunately he has given the password wrong thrice. So there is an password invalid attempt event for me, because we do collect the events about all the customers, because we do have to analyze these events to improve the customer performance or customer satisfaction. You can ask me, hey, how are you going to improve the customer satisfaction based on the events that you are collecting? I'll give you an example now. So now Lakan had locked his account because he has done some invalid attempts. So what would he do immediately? He would call the customer care, right? And he would want to reset his password, right? That's what he would do, the first point. So now, because I have already got the event, that means I've collected the event immediately. What I would do when Lakan calls the IVR, the most probable question that the most probable uh, option that he would be looking at as password reset, right? So what we would do is, because the probability is very high that the customer calls the IVR and says that he wanted to reset the password, and I already know that he has locked his password, what I will do is, in IVR, the first option that I would set is, when Lakan calls, hey, Lakan, we see that you have locked your password. Are you calling us to reset your password? Right? So if I say so to Lakan, he would be more impressed and he would be more satisfied, because he did not go through all the entire process of your IVR. Right? So what I would do is, as soon as the password lock happens, I would generate a temporary password and I would link it with my IVR, so that my IVR would pronounce that to Lakan, saying that you have reset, you're trying to call, you've locked your password, do you want to reset your password? And within no time, if he is given a temporary password, the customer satisfaction increases. So you're analyzing your events in real time, right? You're analyzing your events in real time and you're trying to update your customer, which increases your customer satisfaction, as well as that in turn increases your organization productivity. So that's one classical example that I can give you for real-time processing, right? Coming to near real-time processing, it's simple. You are calculating all the transactions. You are calculating all, you're gathering all the transactions of a customer, and you would validate IP address. Let's say you are validating IP address. So, or rather than IP address, okay, let's take it this way. Maybe you're working for some e-commerce sites, right? So what you're supposed to do is, you wanted to collect all the cart information. For example, let's say Sidhu had added some products into his cart, right? So I would collect all the cart information from my e-commerce website, and I would wait for 1 hour and drop an email to the customer saying that, you would have observed that when you have left few items in your cart, maybe after 1 hour you would get an email from your e-commerce site stating that, hey, you have left few items in your cart, and you would also convey them whether the price of that particular products had gone up or gone down. You're intimating customer and you're reminding them in turn. So what would that do to us? It's simple. For example, let's say Sidhu wanted to buy some products, but he has added them into cart, but maybe he has got deviated for some reason. You cannot immediately send him an email alert. You have to wait for 1 hour. Maybe he will be free. And then when you send an email alert, he will look at the email. Maybe he'll then remind, okay, I am supposed to buy something, right? Let me go back and buy it. So how did you get the information? I'm collecting all the cart information for all the customers. I'm collecting that for every 30 minutes or every 1 hour, and I'm sending an email alerts. And again, I'm also doing my analytics in the background to analyze the price of the products available in the cart. So there you go. You're processing your data once in an hour or once in a 30 minutes to alert your customer. Again, that improves your the I'm sorry that improves your company's turnover or something, or the amount of transaction that happens within your company. So that's another example that I could give you for near real-time processing. And there is a question here. Hadoop is not good in processing the small data. So how good is Hadoop in real-time processing? Can you give an example? See, Hadoop as such is not good for smaller data. I agree with that. But Hadoop has a lot of echo components on top of it. Let's say Storm. Storm is something that is best fit for real-time processing. So what you do is, Storm will have a different master-slave architecture, which should be in a position to deal with smaller data sets. But yes, Hadoop, while storing the data, you would do some accumulation or you would do some merging while you are storing the data into Hadoop. That answers your query. Basically, you will make it as big when you are storing the end result into Hadoop, right, Ajay? So Hadoop as such is not a better fit for smaller data sets, but yes, there are echo components like Storm, which would be a better fit for would be a better fit for real-time processing, which deals with smaller data set, but it will make sure while it's storing the output into Hadoop, it would merge them into larger data sets. What could be the actual difference between distributions when we analyze the data? Like I told, at the end of the day, any of the distribution do use only Hadoop. So the Hadoop remains same across your distribution. So you may not find much of the difference across the distribution when you are analyzing the data. I would say majorly you won't find any difference. Is Java and Linux required for Hadoop learning? Yes, Lakshmi. I would say Linux is required and a basic awareness of core Java is required, and probably I would recommend you to watch my demo video, which should answer your query in detail. But for your question, the straightforward answer is yes, Linux is required and basic of core Java is required. Can we run batch processing and can we call Hadoop for reference? LT, I'll unmute you because I need some clarity on your question. Just give me 2 minutes. Absolutely, Mukul. When you are running the data processing once in a day or once in a week or once in a month, it is called batch processing. Mohammed Sayed, right? Would you like to show either sooner or later on this course that of course, see, basically when we actually enter into the part of Hadoop, we would do all the practical activities which should answer what a developer or analyst do work in real time, right? What all activities do they perform? That's my major concentration in this course. When we go out of this course, you should be in a comfortable position to deal with any Hadoop related activity on your own. Having said that, I would give all the practical exposure you do require, right? For you to work independently on Hadoop. That's my part. I'm going to do that, Syed. And also I would like to know why real time doesn't work for RDBMS, right? RDBMS architecture itself is designed for batch processing. I'm talking about real time processing. I'm not talking about real time transaction storage or something. Real time processing is nothing but you have to run your analytical algorithms on top of it. But does your RDBMS support the machine learning libraries to work on your data? Probably if you wanted to analyze some data using some machine learning, would your RDBMS support that? The answer is no, right, Lakan? So that's the answer for you. And Sachin, what do you mean by distributions? How do they support Hadoop? See, a simple thing. I mean, Linux is an operating system which has been distributed by Solaris or IBM. Similarly, Hadoop is an open source which is distributed by vendors called Cloudera, Hortonworks, and Mapr. Right? They're packaging all the components of Hadoop together and they're selling it for you. Yeah, Suresh, you will get that going forward, because I need to give you all the jargons, then you'll get to understand how different will be the role of a developer and analyst. Can't we run the queries on OLTP systems instead? Sumit, that's a good question, but if your queries has to run on your OLTP transactions of terabytes, can you run that on RDBMS? No, right? As simple as that. Okay, let me answer. Okay, let me unmute you people who had raised the hand. Mukesh, you still have any questions, Mukesh? No, I don't have. Okay, no problem. I think no questions. Syed, I'll be covering Scoop. Oozy is something that I'll give an overview, because Oozy is not an component as such. It is just an scheduler. It's a workflow scheduler. For any individual, it would hardly take probably a 30 minutes time frame to get well versed with Oozy. So anyways, I'm going to give you an overview on that. But Scoop, yes, we are going to work in and out. Yes, LD, I'm going to unmute you. Yeah, go ahead, sir.
See, I'm working in a big healthcare company. We're doing the batch processing.
Okay.
We have the claim system, which is in billions of rows. But processing, batch processing, running only millions of rows. So you said you can use that Hadoop in batch processing.
Absolutely.
So can we call the worker package? When we're running worker package, can we use Hadoop?
So what was that? I didn't get your question. Can we call?
Yes. Can we use Hadoop in the Oracle package?
No. See, Oracle is different RDBMS, right? And you have Hadoop, a separate system. Maybe what you can do is you can transfer your billions of rows, whatever there in your Oracle, to Hadoop, and then you can do your batch processing. Maybe you can set this way. For every 2 hours, whatever transaction that happens in Oracle, dump it into Hadoop. Anyways, you have to run your batch processing at the end of your day. So at the end of your closing hours, you should have that particular entire day's data into Hadoop, on top of which you can run your batch processing. That is possible. And you can use a distributed mechanism to transfer the data from Oracle to Hadoop, which is using Scoop. Got that, LT?
So see, I have some real-time processing. After real-time processing, we do batch processing daily, night. Then it goes to the client system to the bulk data. So I have to do all separately, right? I cannot mix that bulk.
Yeah, you cannot mix your real-time processing and you cannot mix your I would say batch processing. This has to be two different processes.
So those two are different, but now batch processing and Hadoop I cannot mix, correct? I have to do separately.
Yes, I mean you have to transfer your data to Hadoop, and then you can work on your batch processing, or you can do your real-time processing as well by transferring the transactions immediately to Hadoop as and when they happen. And how do they transfer the transactions immediately to Hadoop as and when they happen? I would convey that later. That, I mean, to answer it in a straight way, it is using something called Kafka, a messaging broker called Kafka, through which you would transfer the data immediately to Hadoop as and when they happen.
Oh, okay. Then I can understand.
Yeah. And Lakan, yes, OLTP doesn't work on Hadoop. Hadoop is only fit for OLAP. Hammond, the entire session would have almost like 40 sessions, right? I mean, entire course will have 40 sessions. Every day there will be one session, and I mean, including weekends, we are going to have sessions. That's one thing. Okay, so let's proceed further. Suresh and Hamant, I would request you to watch the demo video so that you would get a better understanding on what this course covers and how does that cover, right? So I would recommend you to watch that. Probably you just ping me your consultancy name. I would ask them to send you the details, Suresh. I'm having a good knowledge on SQL and currently working as a developer. Okay. So again, Lakshmi, the same answer. When you go through this particular demo video, right, you would get better clarity on this, right? Which all echo components would be fit for you, but you can drop me a separate email. I can answer that in detail. Okay. So now that you understood what is the type of processing available, now I spoke about the distributions. I spoke about the size of the cluster. I spoke about the type of processing. Now, let me tell you one real-time example how this processing can improve your business. I mean, you would have already seen this. I mean, when you go to Amazon or any e-commerce site for that matter, let's say you're trying to buy MacBook. When you're trying to buy MacBook, right, what happens is you just click on it. At the bottom, you might be suggested, hey, you may also like maybe some headset of Beats, right? I mean, different products people, I mean, Amazon would suggest you. How? Right? So it's something Amazon has to do the groundwork. But Amazon, it's not just about MacBook. It could have millions of products available in its portal, right? For each product, would they blindly or manually go and update for a MacBook? I have to suggest Beats headset, and then I have to suggest something called a mouse and a wireless mouse or a Bluetooth speaker. Should I propose them? I mean, should I enter that manually? Then they are gone. So that's where analytics comes in place. That's where Hadoop comes in place. When you have millions of products available, what they have to do is they have to run some association rules. That means previously, when someone had bought MacBook, what all other products have they bought, right? So that's something that you have to collect. Based on that, the most frequently occurred or most frequently bought product is something that I have to propose to this customer when he is buying or when he or she is buying MacBook. As simple as that. But that doesn't look as simple as I'm saying. Building association rules is something that is not going to be straightforward. For MacBook, maybe Beats headset, maybe an Boss Bluetooth speaker. I have two products here, and maybe for MacBook I have some other products as well. But these two are the products that are most frequently bought along with MacBook. So that's what I have to propose. For example, if I'm purchasing some Samsung phone, right? Immediately I would see that at the bottom they would suggest me some protection wear on top of my phone, and they are proposing some other products related to, I mean, again, some headset they're proposing. They could see for Samsung, when customer had bought the Samsung phone, they could have seen many other products the customer had bought, but these are the two important or majorly bought products that they can propose it to the customer. So that's like another thing. Third thing is, suddenly there is a product, no one has yet bought it. How would they come up with association rules? I mean that's called outliers. Outliers are something that a product is there and it's a new product and there are no transactions that had happened so far on top of this product. How would I propose the recommendations for my customers? So outliers has to be calculated. That's again some algorithm has to be run, which is called a priori. A priori is an machine learning algorithm that they have to run on top of such huge data sets. I mean, millions and billions of products that they do have, and they have to finally come up with recommended products for each product available in their portal. So there you go. You have to keep on analyzing your products and you have to come up with the proposals or the recommendations, I should say. So that's where Hadoop is best at. It's gonna analyze millions and billions of rows and come up with a solution. And you would see that practically, right? When you go to Amazon, when you were trying to buy a product, you would find some recommendations for you. That's through association rules. And again, when the data is very huge, you cannot ever do that in RDBMS or any file system as such. Rather, you would do that on Hadoop, right? But you have to understand from our previous discussion that where Hadoop is fit into, where RDBMS fit into. Because now that I'm saying, hey, this is something that I can run on Hadoop, but that doesn't mean that every kind of processing I would be able to run on top of Hadoop. No, because there are certain factors that stops or refrain Hadoop from doing some things, and that is something that I've already conveyed in our previous session. Okay. So, anyways, I'm gonna send the demo video and the day one session to all of you who had attended today, right? I know few of you had already got it. For the people who had not got it, for the benefit of them, I'm gonna send it once again so that you would understand all these basic things that I'm talking about, which are missing today. And you watch that, you definitely can connect the dots. Okay. I could see one hand raised. I will answer that. Yes, Mukesh, please go ahead.
Yeah, I have a question like who decides the like who does the analytical result? As you said, if I'm buying any Samsung mobile, at the down you say, okay, you may interest in this headphone or you may interest in this speaker. So I just have the question: who decides the result? Like, is it like a default or is it like decided by the company or like the developers?
So yeah, good question, but see, when you're talking about probably 100 products or 200 products, you can manually go and check them. Okay, shall I release this? That this recommendation should go and update in my portal. Yes, you can do so when you are having less number of products available. But when I'm talking about billions of products available in the portal, I cannot do that. Rather, I have to build some reliable algorithm, right? That's what I'm talking about a priori. A priori is for your association rules, right? So you will build the algorithm and you train this algorithm with the data that you have, and finally it takes the decision. You need not have to manually intervene there, right? Okay.
Yeah, got it.
Because see, you can ask me, hey, how blindly can I rely on the algorithm? So you do all your validations, right? I mean, it's not that you would blindly go and do that. I mean, you would run your SIT, you would see the results, and you would compare it with the manual comparison, and then only you would go and implement that in your production cluster, right? So yes, you can rely on this machine learning libraries, provided you are training this algorithm in a perfect way. Okay, Mukesh?
Yes, got it. Yeah.
Okay, so probably I'll stop the session here. So I'm not giving you any case studies for today because for the people who had already attended my session would understand that every day there will be session. I mean, there will be questions on Linux, Core Java, and Python. And I've already shared the tutorials with all of you. I mean, at least the ones who had attended the previous session. For the people who had not got that, just contact your consultancy folks. They should be in a position to provide you those prerequisite tutorials, right? For the people who had joined only today, probably I'll check with your consultancy and I'll share all the required materials to you. So that's the update from me. And from starting from tomorrow, I'm gonna give you the case studies on Linux, Core Java, and Python. Okay. So that's it for now, guys. Probably I'll wind up the session for now. Yeah, I'll wind up the session for now. And when we come back tomorrow, we are slowly going to enter into the architecture of Hadoop because I have a few more jargons that I need to cover, which might take another 15 to 20 minutes. And that's when I'll enter into the Hadoop actual discussion part. And yes, I will be sharing today's discussion video as well. So thank you and bye-bye. LT, do you mind dropping an email to me, LT? So the case studies are nothing but the session. That gives you some confidence on all the prerequisites: Linux, Core, Java, and Python. Right? Initially, we would work on them, and later on, we would go ahead and we would work on the case studies related to Hadoop. So when I give case studies, you can reply back to this email, whichever I'm just sending you across. SAP HANA is not my platform, so I couldn't correlate you between SAP HANA and Hadoop, Suresh. So I've sent the email ID to every one of you. You can post in if you have any queries over there, right? So that's it for now, guys. Thank you and good night, or have a nice day. Bye bye.
जे करायचं नव्हतं तेच तू करताय ना मृदा, किती मोठी चूक करताय. अरे राहू दे ना या. अरे तू जरी घरी बसलीस ना तर आणखी काहीतरी नवीन काढेल. बरोबर होईल ना.